Hello, students. Today we've got some of the exponent properties. So there's a lot. To be honest with you, there's a lot of properties going on with exponents. But what we're going to be able to do is kind of break it down into a couple different days. So there's a few I want to focus on today, all kind of revolving around some sort of multiplication. So the first one, product of a power. So when we're dealing with a power, first of all, okay, you've got your base, okay? The base is the number that is being multiplied X amount of times, okay? So your base number is that number with the exponent on top of it. And then the exponent is obviously that little number up top. So you've got your exponent, you've got your base, okay? And then when you see that word power, that technically means the whole thing, okay? So it's that whole individual term. So that's typically how that's going to be referred to. But base and exponent are kind of the main points of that. So when you have a product of a power, so what we're dealing with right now is really the multiplication property, for the most part, is when you're multiplying powers that have the same base, okay? When you multiply powers that have the same base, you add the exponents. So when we're multiplying powers with the same base, so when they both have a base of 2 here, okay? 2 squared means that I have 2 times 2. 2 cubed is saying I have 3 2's multiplying by itself. So altogether, we end up with 2 2's and 3 2's all multiplying by each other, which gives us a total of 5 2's. So we would end up rewriting this as 2 to the 5th power. Okay, so that exponent, all an exponent is, it tells you how many times that base is multiplying by itself. Okay, so today I'm not too worried with you guys telling me what that's equal to. We just want to simplify it into one power, okay, one expression. So again, we end up with 4 to the 5th power. So there's 1, 2, 3, 4, 5 4's being multiplied by each other. And then 4 to the 2nd power, which has 2 more 4's multiplying by each other. So since these bases are both the same, I have all 4's, and I end up with 7 of them that are multiplying by each other. So I would rewrite this as 4 to the 7th power. That's all that's happening with that property today. We're just seeing how to simplify those, okay? So a to the m times a to the p will be a to the m plus p. You're just adding those two exponents together. B squared times b to the 4th will end up as b to the 6th. Doesn't matter if we're dealing with numbers or exponent or numbers or variables, whatever. Those are all going to come out to be the same, right? So if I end up with something like 3 cubed times 3, first of all, when you have an exponent, when you have a value that doesn't have an exponent on it, it's always technically an exponent of 1. We just never write that up there, okay? So what you're seeing here is we have 3 times 3 times 3, okay, in that first term, 3 cubed, and then times a 3 all by itself, I end up with 4 total 3's, 1, 2, 3, 4, and I end up with 3 to the 4th power. That exponent just tells me how many of that base do I have, okay? So then look at another one, w squared times w to the 5th, okay? I would end up with, all I need to do is 2 plus 5. I end up with w to the 7th. That's all that's happening, okay? Now, power of a power, this is basically what's going on here is when you have an exponent, and then that term itself is being raised to another exponent. So let's kind of break this down here from the outside in. So if we're going to the 3rd power for everything inside those parentheses, that means I have this 3 to the 4th power happening 3 times. Now within each one of those, I have 4 3's. right? 3 to the fourth is 3 times 3 times 3 times 3. That's the first one. The second one, again, is 4 more 3s. And that third one is 4 more 3s. So I have this group of 4 3s being multiplied by itself happening 3 times. So what I end up with is however many total 3s I've got in front of me, and it's going to be 4 plus 4 plus 4 is 12. I'll get 3 to the 12. And that is why it makes it easier to learn this rule first, because once you get to this step here, 3 to the fourth times 3 to the fourth times 3 to the fourth, that's just this rule happening a couple times, right? If I were to have another example on that last rule, if I had something like a squared times a to the third times a to the fifth, it doesn't matter how many different terms I have, you're just following that same rule of adding them all up. So I have 2 plus 3 plus 5, I would end up with a to the 10th. Okay? So over here, when you've got those two exponents, where one exponent is inside the parentheses, and then that whole term is being raised to another exponent, if you can pick up on the rule right now, you multiply the two of them. 4 times 3 will give me 3 to the 12. Okay, you don't need to write it all out like this. You can if you see it better that way, but you don't have to. Okay, because once again, we look down here, r squared to the fifth. So to the fifth means I have this r squared happening 5 times. So if I wrote it all out like I did on that first example, I would have r times r times r 10 times. Okay? If you write it out this way, which is rewriting it along the first rule that we learned, since I'm multiplying all of these powers with the same base, I would add 2 plus 2 plus 2 plus 2 plus 2, which is fine. You'll still get r to the 10th, but the even shorter, even quicker shortcut to this rule is that when you have a power to a power, so an exponent raised to another exponent, you're just taking 2 times 5, you multiply those two exponents, and you'll end up with your new exponent, in this case, of 10. Okay? So here for that rule, a to the m all raised to the p is going to be a to the m times p. Okay? Multiply the exponents. So b squared to the fourth power, I just take 2 times 4, and I'm going to end up with b to the 8th. Okay? So if I have something along the lines of a squared to the third, right? Technically, I have a squared happening 3 times, which just is really just a shortcut on top of our first rule. If I rewrote my a squared to the third like this, 1, 2, 3, I know the rule from the first slide where they all have the same base, so I add their exponents. Or you could just say, okay, 2 times 3 is going to be 6, so I'm going to end up with a to the 6th. Okay, both of those are going to end up with your same final answer. All right. So now if you have like 2w squared to the third, here's where you need to be careful. Okay, if you have like a number in front, a coefficient involved, that's part of what you're squaring. Okay, you'd have 2w squared times 2w squared times 2w squared. Let's look at this other example here for a second. Okay, so if I have this situation with my first rule, if I have like a 2a squared times 3a to the fourth, well, the rule about the exponents, the 2 and the 3 are not part of your base. So some people will say, well, I can't add those exponents together because they have different numbers out front. The base is just the variable that is being raised to the exponent. It's just whatever's being raised to the exponent. So for 2a squared times 3a to the fourth, the a squared and the a to the fourth, I end up with 6a's. Really, if we break this multiplication down, 2a squared is 2 times a times a. And then the 3a to the fourth is 3 times a times a times a times a. There's 4 a's there. This is just one long string of multiplication, and you multiply whatever you can multiply together. So I can multiply my 2 times my 3, which is 6, and I can also multiply all these a's together, which I have 6 of them, okay? 2 plus the 4. and I end up with 6a to the 6th. So when you're dealing with terms that have numbers in front of them, you're multiplying them like you normally would. These rules just apply for where the exponent is involved. So again, if I have 2w squared times 2w squared times 2w squared, this essentially is 2 times w times w times 2 times w times w times 2 times w times w, right? So I have 2 times 2 times 2, which is 8. And then I've got 1, 2, 3, 4, 5, 6 w's involved, so I have w to the 6th. Or if you use these shortcuts, 2 to the 3rd power is 8, and w squared raised to the 3rd, we just multiply those two. 2 times 3 is 6, and that's where you end up with your 8w to the 6th. Okay? You can see another one of those for a second. So if I go ahead and I see negative 2x squared all to the 2nd power. Actually, let's do, let's do the 4th power. Okay, well, first of all, it doesn't matter which one you deal with first here. Negative 2 times negative 2 times negative 2 times negative 2. That is negative 2 to the 4th. What that's going to end up giving you, negative 2 times negative 2 is 4, times negative 2 is negative 8, times another negative 2 is 16. So negative 2 to the 4th is 16. And then my x squared to the 4th, I just multiply those two. And I end up with x to the 8th. And I end up with 16x to the 8th. So when there's a coefficient out front, just make sure that's getting the same variable or the same exponent treatment. You just multiply that out. Okay, these rules are with the exponents on the variables. And lastly, the power of the product. Really all this means is that you are just making sure, this is kind of a combination of both of our first two rules. You're just making sure that everything inside of those parentheses is getting that exponent attached to it. Kind of like we've already been doing, right? If you have that 2w squared, you have to have the 2 that's being raised to the 3rd, and you have to have the w squared that's being raised to the 3rd. Okay? So for examples like this, if you have, let's say, some variables, if you've got like a squared b to the 3rd, all raised to the 5th power, okay? This is a squared times b cubed happening 5 times. And each of those is happening 5 times. So if we're going back to our first rule, 1, 2, 3, 4, 5, a squared happening 5 times, that's 2, 4, 6, 8, 10. I have a to the 10th, and then I have b to the 15th. Remember, you can always just multiply those exponents when it's power to a power. So I have a to the 10th, b to the 15th, and that would be your final answer. Okay? Whoops. Okay? So you see something like this, 2ab cubed, and then all that's going to be squared. You need to be squaring your 2, you need to be squaring your a, and you need to be squaring your b cubed. So all those different rules are going to apply. 2 squared is going to be 4, a squared is just a squared, and b to the 3rd b to the 3rd, and then to the 2nd, you multiply that 3 times 2, you get b to the 6th. Then the last rule is one we should probably all know or be familiar with, the zero property exponent. Zero exponent property. Anything raised to 0 is 1. It's not 0, okay? A to the 0 is 1. 3 to the 0 is 1. X, y to the 0 is 1.